Hello, beautiful people, and welcome. In today's video, we will be discussing and introducing the leading coefficient test for polynomials. Now, a polynomial, we're going to start defining this. Disclaimer time, as always. If I make a mistake, let me know so we can learn from my mistakes. All right, so polynomials. And this is a polynomial function. We're going to define that as, let me get a black pen, please. So let n be a non-negative integer and let a sub n, so it's a with the little n on the bottom, comma, a sub n minus 1, so a with n minus 1 as a subscript, comma, dot, 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 comma, a2, comma, a1, comma, a0 or a naught, be real numbers with a sub n not being equal to 0, the function defined by f of n, or f of x, excuse me, is equal to a sub n times x to the n power plus a sub n minus 1 times x to the n minus 1 power plus, we're going to dot, dot, dot that means it's continuing. And then we have a sub 2 times x squared plus a sub 1 times x plus a sub naught. Okay. All of this is called a polynomial function of degree n. Now, here's where I stop and I'm going to put my 2 cents in. We are not dealing with polynomials right now. I'm introducing this early so we can practice using the leading coefficient test. So when we get to polynomials, we're going to be really comfortable with it. What we're doing today, the leading coefficient test, can be used for any sort of polynomial. It doesn't matter what the degree of the function is. It can be a quadratic, a cubic. It can be whatever you need it to be, but this test will work. So the next part information that I'm going to write down is super duper important. That's why I wanted to give you this definition. The number a sub n is, so the number a sub n is the coefficient of the variable to the highest power. Is called the leading coefficient. Okay, that's the most important information for me. I'm going to take out a highlighter and we're going to translate this. Let n be a non-negative integer and let a sub n minus 1, a sub 2, a sub 1, a sub naught, or a sub 0 be real numbers with a sub n not being 0. All that means is whenever you have a polynomial, whenever you have a function written out that has exponents, these right here, the a sub n's and the a sub 1's, those are just coefficients. Those are just a really fancy way of saying, hey, there are numbers in front of x. Here's the first number in front of x. Here's the second number in front of x. So it goes down. Because we're saying whenever we write these, we write the highest exponent first. This coefficient belongs to this exponent. this coefficient belongs to this exponent. So notice how the ends match. So all of these match. A sub 2 goes with x squared. A sub 1, and even though there's nothing here, there's a secret 1 because if it's 1, we don't write an exponent. This one does not have an x because this is x to the 0th power. Anything to the 0th power is 1. But notice that this coefficient belongs to this x. This coefficient belongs to this x. So the degree of n. So this right here, this n is your degree. This is your power, your exponent. Okay, so n is your exponent. So if we start out with exponent 5, the next term has to have an exponent smaller than that. So like x to the 4th power. And then it keeps decreasing as you're going more to the right. So more to the left is higher exponents, more to the right are lower exponents. And when you see an example, you'll know exactly what I'm referring to. It starts out with like x to the 10th. Then you have to go x to the 9th, x to the 8th, to the x to the 7th power, x to the 6th power, all the way. So here's the dot, 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 all the way down until you get to just the constant without any variables next to it. So the a sub n is the coefficient. And the coefficient we're looking for when we are doing the leading coefficient test is the one attached to the highest power. So we want a sub n attached to the highest power to get the leading coefficient. Now, the ones that we're going to be working with initially are going to be factored. So whenever things are factored, you're just looking at the coefficient out in front of whatever is factored. Again, we'll do more examples. But if it's not factored, if it's in expanded form, we want the coefficient that is attached to the highest power of the variable. Okay, so let's go ahead and actually do this leading coefficient test. There are a few things that we need to know for the leading coefficient test. I'm going to go ahead and do a graphic organizer for you guys. I highly recommend making this graphic organizer and keeping it handy because you will refer to it many, many, many times in our semester. Actually, you know what, in the entire school year, because we will be using this next semester as well. There are a few things we're going to use the entire year. This is one of them. So we're going to retitle this as leading coefficient test. I'm going to define things. So n is the total degree of the function. And I abbreviate function as f and c. I'm going to leave some space here because I want to define things. And then a sub n, so a with n little, this is not an, this is a sub n, is your leading coefficient. And I'm going to abbreviate coefficient with as coef. Okay, so two things, total degree of the function. If it is factored, if you have a factored function, then you're going to add all exponents. If it is in expanded form, you're going to choose or select the highest power. Okay, leading coefficient, if it is factored, you're going to select the coefficient out in front. And if it is expanded form, you're going to choose the coefficient of the highest power. Let's say of the variable with the highest power. Okay, Now that we have determined those, again, when we're doing these graphic organizers, you guys, at first it's going to be a little bit confusing because we don't have examples to work with, but once we work with some examples, all of this will make sense. I absolutely promise this. So we have two things. So I'm going to go back up here. I'm going to draw two arrows, one here, one here. So when we're doing the leading coefficient test, we're looking at two things. We're looking at the total degree of the function, and we're looking at the leading coefficient. So when n is odd, I'm going to put that in a bubble. So when n is odd, again, one is n is the total degree of the function. So we want the total degree of the function to be odd. Odd is what? What numbers are odd? 3 is odd, 9 is odd, 7 is odd. So make sure you're looking 3, 5, 7, 9. Those are all odd numbers. So when your total degree of the function is odd, you have two choices. There are two choices for you. The first choice is your leading coefficient, your a sub n, can be positive, or you can have your leading coefficient be negative. I don't care about the number out in front. That number can be whatever it wants. All I'm looking for, if my leading coefficient is positive, it means something. If it's negative, it means something. The numeric value matters for your variable exponent. So your exponent of the highest power, or when you're doing your total degree of the function. Okay, so if it is positive, on your left-hand side, your graph goes down. On your right-hand side, your graph goes up or to the right. So it kind of looks like it's going down and to the right. So how would this look like? Let's do an example. If you have an odd function and it is positive, it is an increasing function. And you are increasing from left to right. Put that in a thinking bubble. So here's my left-hand side. Here's my right-hand side. So it is increasing from left to right. Now, it doesn't matter what it looks like. It can look something like this. All we care about is your end behavior. For the leading coefficient test, we are looking for end behavior. It is going down and it's going up. Whatever happens in the middle, doesn't really matter. We'll figure that out later. Okay, let's do, if it's negative, that means we have a decreasing function. And we are going decreasing, so we're going down from left to right. So what type of behavior do I have for my negative coefficient? So if I'm decreasing from left to right, so on the left-hand side, it must be higher, and my right-hand side must be lower. So how would that look like if we have an odd function? We have an odd function that is decreasing from left to right. So that means on the left-hand side, we're going up. On the right-hand side, we're going down. And here is another example here. Now, this is x cubed as an example. And we are going negative, so we're putting a negative out in front. Let's make that a little bit bigger, easier to see. We have a negative x cubed on this one. All right, so when n is odd, so when your exponent, your total degree of the function is odd, and you have a positive, you have an increasing function, it's going from left to right, you're going up. If you have a negative as a coefficient for an odd function, then that means you are decreasing from left to right. So now let's do even functions. When n is even, when our total degree of the function is even. If you want to know what even numbers are, just count by twos. Multiples of 2 is 2, 4, 6, 8, 10, etc. So again, we have two things. We have it when it's positive and we have it when it's negative, and it is referring to our leading coefficient. So when A sub n is positive, our leading coefficient is positive, something happens. And when A sub n is negative, also something happens. Now for even ones, it's the same thing. So for even, we have, let me actually put a thinking bubble. Left and right match. So for odd functions, your left and your right hand side are going to be different. Things are going to be either going to up or down. Left hand's going to go up, right hand's going to go down, right hand's going to go up, left hand's going to go down, etc. But for even, your left and right match. So if it's positive, you have an increasing function. So same thing, increasing. However, because they match, where your left hand side and your right hand side are both going to do the same thing. Increasing function. That means we are going up. So an example of that would be like a quadratic function with an exponent of 2. And we would have something that looks like this. So our left hand and our right hand are both going upwards. Now if it's negative, we have a decreasing. And again, if we need our left hand and our right hand to be the same, then if we're decreasing, we're going down. So that means, and again, we'll use the quadratic function as an example, that means we're going down. Now the middle part, whenever we work on graphing polynomials a little bit more, you're going to notice that the middle is determined a different way. So this leading coefficient test only tells you the end behavior. It tells you how your arrows are going to be positioned in your graph. All right, beautiful people, make sure you have this graphic organizer with you at all times. Make sure you put it in a safe place. Make this graphic organizer and keep it. Again, we will be using this many, many, many times during this school year. If you find a mistake, please let me know. Other than that, thank you for watching my video, and I will see you in the next one. Bye.